Hello everyone and welcome back to the GCSE Maths series. Today we're going to be looking at probability trees. So let's get straight into it. So to understand what we're doing today, we need to first understand what a probability tree is. So a probability tree is used to represent a compound probability. And a compound probability means more than one event. So we need to work out the probability of more than one event. We do this using the tree. So to start with the first event, we have to pick, for example, a counter out of bag A. And we need to draw branches for each outcome and label with probabilities. So this is going to look something like, say we have event A. I'm not going to be as specific as saying bag A, but we have event A, and let's say we have two outcomes. And let's say these two outcomes are going to be yes or no. We then have a probability. So we say 1/2, 1/2. So it's 50-50 whether we go from here up to yes or down to no, depending on what happens in event A. Now looking at event B, we then have our yes and our no. Say the probability in event A is 1/4 to say yes and 3/4 to say no. So we draw that down here as well. Yes and no, 1/4 and 3/4. The reason why there's two different things is because, say we were told no in event A, but then we were told yes in event B. Whereas we could be told yes and yes, or we could be told yes then no, or no then no. And the way we are to calculate our total probabilities, our compound probabilities, is to say we are told no and no. So the probability of no and no is going to be equal to 1/2 times by 3/4, which is equal to 3/6, which is equal to a half. 3/8 actually, so it's not equal to a half. So that's going to be 3/8, like so. Now, looking at our example, it tells us Ben has 2 bags of sweets. Bag A containing 4 red and 6 blue. Bag B contains 3 red and 5 blue. Ben takes 1 sweet from bag A and 1 sweet from bag B, and we have to draw a tree to represent our probabilities. So we start off with event 1, so bag A. Let's say the two outcomes are red and blue. As such, the probability of getting a red one is 4/10 or 2/5, but to keep it to 4/10 just for simplicity, so 4/10, and then this one is going to be 6/10, right? That makes a lot of sense. The bag B, we're going to have red and blue once again, and then now we have that the probability is going to be 3/8 because there's 8 sweets in there for red, and then 5/8 for blue, and we're going to write that back down here as the same above. So 3/8 there, 5/8 there. Okay, we have to learn how to calculate the probability of a specific combination of events. I just talked about this in the previous slide. So we have to multiply along the branches that we use, and each path on the tree is equal to one outcome. So from start to finish, that's a possible outcome. And then we have to simplify our answer if it is possible. So let's see. It tells us to calculate the probability of blue and then red. Oh, blue and blue, sorry. So we look at here and we see, okay, in the first bag, we choose our blue. And then also in the second one, we also choose blue again. So we follow this path, and this is going to be equal to 6/10 times by 5/8. Because remember, we times along the path. So we have 30 over 80, which is equal to 3/8. And we can write that here. Now, the probability of blue and then red is going to be 6/10 times by 3/8, because we're following along the path and multiplying our branches. We get 9 over 80. And can that be simplified? I don't believe it can. Okay, so this is going to be 9 over 80. Now the probability of red and red, we follow the top paths, and we get 4/10 times by 3/8, which is going to be equal to 12 over 80, which is going to give us 6 over 40, which is going to give us 3 over 20, and that is our simplified form, 3 over 20. Okay, now we have to look at another concept that comes up in this topic, so the probabilities of multiple outcomes. So we need to learn how to find the probability of multiple outcomes combined. And this comes in the form of at least one blue, or either red or blue, or something like this. So looking at the next question, we have a bag contains 5 red and 3 green. A ball is chosen at random, then replaced, and a second ball is chosen. So what is the probability that Ben picks at least one red ball? Okay, this is a perfect example of what a question could be like in your exam. So we have our first pick and we have our second pick. So we're going to have red and green. So this is going to be 5 over 8. This is going to be 3 over 8. Then remember, the ball is replaced. So say I take a red ball out, I put a red ball back into the bag to make it the exact same as before I picked the first ball. So the probabilities are going to remain the same, and say 5/8, 3/8 here, 5/8 are here, and 3/8 are here. We have red and green here once again. So we need to find the probability that Ben picks at least one red ball. So at least one means we can choose one, or you can also choose 2 red balls, right? So what we do is we first see, okay, so red and red is 5/8 times by 5/8, which is equal to 25 over 64. Then we look at red and green, because red and green, he at least picked one red ball. So 5/8 times by 3/8 is equal to 15 over 64. Then we have green, and then we need to go to red. So green times by red is 3/8 times by 5/8, which is going to be equal to 15 over 64. Now, to work out the total probability of our question of at least one red ball, we now add these probabilities together, because these are all the combinations that we can get for Ben to choose at least one red ball. This is going to be 55 over 64 as our final answer. Okay, moving on. We are told that Amira flips a fair coin twice. What is the probability that she gets at least one head? So we have first flip and we have our second flip. We can get heads or tails. Notice how she says it's a fair coin, meaning that the chance of heads or tails are going to be equal, which means it's 50-50. So the probability of each one is going to be a half. So a half, one half, one half, one half. And we have a half and a half like that. We need to find the probability that she gets at least one head. So the combinations we can have are probability of head and head. So We can have probability that we get head and head. We can get the probability that we can get a head, then a tails. We can also get the probability that she gets a tails and and a head, sorry, in the second flip. So the probability that she gets head and head is 1/2 times 1/2, which is going to be 1/4. Then the probability that she gets head, then tails, so head, then tails is again 1/2 times by 1/2, which is equal to 1/4. Then the probability she gets a tails, then a heads is 1/2 times 1/2, which is equal to 1/4. Now adding these all up, we will get 3/4. So she has 75% chance that if she flips a fair coin twice, she'll get at least one head. Okay, that's going to conclude today's GCSE revision series on the probability trees topic. I hope you guys enjoyed. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video.